And I will speak about diglossia and the brain. New insights into the neural basis of diglossia in Arabic, or insights into the, I don't know how much these are really very new to all of us. Then I will present two studies that we performed here using ERPs and DEG analysis on the issue of diglossia in Arabic, and I will start by some definition. Just to remind that when we speak about diglossia in Arabic, we are speaking about the existence of two forms of the Arabic language. The one which is the highly codified version of Arabic, which is called by, which Zohar likes to call Fusha, because it's the Arabic word for that. I will call that LA for literary Arabic, and spoken Arabic, which is the dialect used almost everywhere in the Arabic world. The question is really if we can speak about two languages, because there are several reasons which make some authors consider these two varieties of Arabic as two different languages. And the first reason stems from the history of acquisition of the two varieties of Arabic. SA, which is the spoken language, is acquired first at home, first spoken, and thus represent what one can call the mother tongue, or the first language of all Arabic speakers all over the world. LA, which is the literary form, is first encountered at school and acquired through formal education, through explicit learning, and can be considered as a second language, LA. The question really remains whether SA and LA really represent L1 and L2. Some author, in particular Prof. Asaid Khateb, says or report that the differences between the two varieties of Arabic appear in the different linguistic domains, which include the phonological, the syntactic, and the morphological, and the lexico-semantic domains, which mean that they are different, they might represent two languages. This is the first evidence. Arabic speakers behave as bilinguals. Early exposure to LA, some studies from Yadar and Prof. and others, show that early exposure to literary Arabic increases metalinguistic abilities of Arabic-speaking children in the same manner as for those who are exposed to two languages, which are, in this case, Russian Hebrew-speaking children. They behave as bilinguals, then they are bilinguals. This is the second assumption. The third one, SA as the first language and LA as the second language. We have research in bilinguals which shows when using priming paradigm, that for word priming, that means when we have the first word in L1 and the second word in L2, we have a larger priming effect when it is the other way around, which that means when we present the first word in L2 and the second word, the target word, in L1. Professor Ibrahim and colleagues assess this relationship between the two forms of Arabic and with Hebrew using semantic priming in auditory lexical decision tasks, and they showed that priming effects were twice larger when the primes were in SA and target words were either in LA or in Hebrew. That means for word priming were larger than when primes were in LA or Hebrew and targets in SA. SA is the dominant language, as according to the results of this study. Conclusion, SA and LA are represented as an L1 and L2 in the cognitive system of literate native Arabic speakers. Okay? that is in the auditory modality. However, several years before, Bintin and Professor Shlomo Bintin and Professor Ibrahim showed using lexical decision tasks on the visual modality and word naming tasks, reading aloud, with written LA words and written SA words and non-words, and they showed that recognition of SA words was slower than LA words in the written modality for the both SA and LA, and they showed that written SA words were processed as low frequency LA words. From these results, we assume that the status of SA and LA is modality dependent, which means that in the visual modality, the visual written modality, LA functions as the dominant language and SA as the less dominant, and in the auditory modality, SA functions as the dominant language and LA the variety, let's say, instead of language, and LA as the less dominant variety. And to test this assumption, we went to do lexical decision studies to investigate the brain responses related to the processing of the same list of SA and LA words, first in the auditory modality and secondly in another group of subjects in the visual modality. Okay, these are the aims, and as always we taught Hebrew as a formal second language as a control condition. In the auditory modality we have 31 young students, adult. Stimuli were words from SA, LA and Hebrew, and we have pseudo words. Since we are interested in the process of recognition or of recognizing words, we are not interested at all in the analysis of pseudo words. We are interested how this subject process words from either variety or Hebrew. We assess familiarity because, as everyone might know, that it's difficult to assess word frequency in SA. Then we assess familiarity in all languages together with Hebrew, and we suppose that this measure is quite rare to say that we have average familiarity, which is equivalent in the field. We record the EEG from 64 recording channels. We analyzed from the 31 subject, 23 subjects, and others were rejected due to many technical difficulties. ERPs were analyzed from stimulus onset to 800 millisecond post stimulus using per point t-test on all electrode and time frames. And here I have to specify because we have no prediction at all which components in the auditory modality, which time windows might be differentiating these conditions, and this analysis allows us to have a global picture to see where differences might be expected. Okay, ANOVA analysis was then conducted in the mean amplitude of some time periods of interest, which were already inspected by the point-wise T. Here you have the reaction time analysis, which showed that SA, in terms of response speed, was the fastest one. Then with LA and Hebrew, not really different, okay? With some trend for LA over Hebrew, but really not different. And at the electrophysiological level, we have the analysis here which compare each variety, SA versus LA, SA versus Hebrew, and LA versus Hebrew. And what we have here is that this first time window, which is around 300 milliseconds, 350 milliseconds, you have many significant differences between SA and LA, and many significant differences between SA and Hebrew, but no difference between Hebrew, LA and Hebrew. Okay, and here you see what is that called the T-map, which shows the difference in terms of nerves, and the two electrodes which differentiated these conditions. And here you say that we have almost nothing in terms of difference. In the second time window, which is the second most interesting time window, in which we have a lot of differences and over many time frames, which occurs here around 600 milliseconds, you see that there is no difference between SA and LA at all. Still, there is a difference between SA and Hebrew and between LA and Hebrew. Okay, these differences were analyzed in the two different time windows using the mean amplitude of the signal. For the RB, you see this measure effect here and this second measure effect, where you see the black is for SA, the red for LA, and the green for Hebrew. Here you see that which is really different is SA, and here which when you see at 600 milliseconds, which is really different is Hebrew, the green line. Okay? So, when we look at these two time periods that I defined here, the first one, the global field power, which represents the spatial standardization of all electrodes together, which gives just one measure look at all electrodes, to see that this time period corresponds to what I call here the P2 component, because we have the first positivity here, a sort of bilateral negativity here, and a positivity here again. And the second one, I call it the late posterior negativity, because the map is dominated by negativity at the posterior part of the skull. Okay? This analysis, as you see here, show that during the first time period, the SA differed significantly from LA and Hebrew. And with all these effects that I described here, I want to go to details, but we have a clear language effect, significant, both at the level of posterior side and at the level of anterior side, which are electrode frontal level. Okay? The ANOVA, which we performed at the level of the late posterior negativity, is presented here, and you see here that, which is really different, okay, is Hebrew and Arabic. SA and LA doesn't really differ between. Okay? The summary of the results, we showed that in terms of RTs, SA differs from both LA and Hebrew and behaved as the dominant language variety. P2 component, the response amplitude was larger in SA than in LA. The two later not differing. In the level of the late posterior negativity, SA and LA behaved similarly and differed both from. These results taken together in the auditory modality confirm that SA holds the status of the dominant language. As for the diglossic issue, our results suggest that during some processing steps, SA and LA behave differently, while in other steps they behave similarly, and both differ from Hebrew, which is a formal second language. That's in the auditory. In the visual modality, we have exactly the same task, but we present written words. We have 64 channels, 29 subjects. We have ERP waveform analysis from stimulus onset 800 milliseconds. And here we predicted that the earliest differences between the conditions should be found at the level of the early orthographic or early recognition, word recognition steps. Then we went directly to some ERP components that we knew that they might be modulated by the orthographic analysis of the word. Okay? Here we have the reaction time analysis, which showed that in this case, the dominant language, the dominant variety is LA, which differs from SA and which differs from Hebrew. And one interesting thing here is the fact that still everyone says that SA has no written form. Still, Hebrew has written forms in the head of all these very proficient students. Still, they recognize SA words much faster than Hebrew word, a language in which they are immersed in everyday life. They have been taught Hebrew during at least 9-10 years, and they are using Hebrew as their teaching learning language at the university level for several years. I don't know how to speculate about that, but it's a fact that means that still SA words are read, recognized faster than Hebrew, which remains a formal second language. Okay, the level of detection, deprived here, you see that the highest accuracy is in LA, followed by SA, followed by Hebrew words, effects which are significant. And at the electrophysiological level, we went directly to the analysis of this first complex that we call the N1P2 N2 complex, which starts with the N, the component in ERT, which is called the N170 or N1, followed by this second component, which is the P1, the P2, and then by the N2 component. We performed analysis using the mean signal over each of these periods, and we found that differences were significant at the level of the P2, the one that follows immediately the N170, which is related to orthographic processing in many studies in several languages. And the same difference was found at the level of the N2, which follows the P2, which shows that we have the highest amplitude for the P2 for LA, followed by SA, followed by Hebrew, and here we have exactly the same thing. As for lead differences, because we have also lead differences that we detected based on visual inspection, as you see here, in several electrodes which are centroparietal electrodes on the left side and on the right side, and which correspond to the period of the P600 component. You see that the map for the three conditions, the three linguistic language conditions, are really very similar, and we analyze the amplitude and the latency of this component, which occurs about 600 milliseconds later. And as you see here, the highest amplitude is for for LA, which again shows a certain dominance over SA and Hebrew. And when we look at the latency, at the time latency of this component, which is analyzed here, you see that it occurs, the peak amplitude of this component occurs first for LA, then for SA, then for Hebrew. The results presented here in terms of RTs and accuracy showed that LA differed from both SA and Hebrew and behaved as the dominant language variety. The results of the P2N2 complex show a relation between the ease with which the words are recognized, as attested by RTs and accuracy, and the amplitude of these responses. This observation is also true for the P600, which showed a modulation of its amplitude and latency by the language variety, with LA eliciting the highest amplitude and the earliest response latency. Taken together, the results of this study and the visual modality indicate that LA holds the status of the dominant language, and this language variety behaves as such during all the stream of information processing during word recognition. Our two studies confirm that at the level of single word processing, I'm speaking about single word processing, the status of SA and LA in the cognitive system of Arabic speakers is modality dependent in such a manner that we already proposed in another paper, speakers of Arabic have two first languages. My thanks go to all my colleagues and students who contributed to this, to these two studies. Thank you very much. Yes.
So how did the words written? Were they written in Arabic orthography or Hebrew orthography?
No, Arabic.
So
Arabic words in Arabic.
Okay.
And Hebrew.
Okay. And do you think that any of the relations there, the differences in relation
terms of RPs and activities. Okay?
The fact that in the auditory modality
600 millisecond time range. There is no difference at all. And I have evidence, some evidence like that in naming tasks with ERP to show that there are processing steps where no difference exists at all between SA and LA. Still, differences existed between the two varieties together against you.
So what do you think about that?
I'm thinking about that. I think that there are two facets, two sides of the same coin, which I can call the Arabic language system, which has.
So do you think I think it's really interesting that there's a different timeline. Okay, so you had in the first timeline, the first week had a difference between LA and SA, and in the last one had a difference between LA and SA, and in the middle they were both similar and different. It would be something like, right, so you have a 300 millisecond, then you have 600 milliseconds.
And which modality?
I thought it was in the auditory.
For digital modality, we have the first difference at 350 milliseconds between SA
Can
and
you
G.
show the slide? No.
Yes. We have to. I know that. It's not that one. Yes.
So in the first
The
one,
first says that here between LA and SA there is LA and Hebrew there is no difference.
right.
Why between SA and LA there is a difference, and between
Right.
SA and Hebrew there is a difference.
And in
Here it says that between SA and LA there is no difference.
exactly, it's the opposite.
Yeah.
It turns around. So there's something going on. We've got a timeline.
Yes, there is a timeline. That's why I'm analyzing millisecond after millisecond to show that in terms of the whatever first recognition of the word, because we are familiar to that in the auditory modality, we recognize very early patterns of SA words because we are the most familiar. The language, the variety with which we are the most familiar in the world, these are these patterns. And here's something differentiated. After that, and the question for me remains at the level of SA-LA. After that, there is no difference between SA and LA. Whatever difference we can find, it could be even later, might remain differences related to reaction time because we have recognized earlier one, and then we have to press earlier for the one that we recognized earlier. But during the time period where both differentiate from ego, there is no difference between them. And this is the point. Yes, it's a little time because we present auditorily, and we know that when we present auditorily, we don't present a word for 150 milliseconds. We present for the whole period of the wording, and the whole period of the wording is something between 8 and 1,000 milliseconds to present the word. Okay?
So this is from the beginning of the word.
From the onset of the word. From the onset of the word, probably what we identify very fast, very rapidly. I'm not what does that change. I'm defending my point of view. And I will continue to defend that because I think that we have a system which is composed of one face and the other. And there is evidence that shows that a lot of processing steps which are in which LA and SA are processed in exactly the same manner. And it depends on the model. And this is the point. There is no absolute dominance in the system for SA and LA. There is a modality dependent dominance. Okay, thank you very much.
So the lunch break until 2:30 and then